In this video, I would quickly like to showcase to you the steps we have to take so we can prepare our digital three-dimensional model, flatten it out into a two-dimensional representation for the laser cutter so that we can, once everything is cut, glue everything back together and we will look exactly like your computer model. So for example, here I have a very simple representation of a room, two windows cut out and a door. And you see it's just all one object. I have 8 inches of material thickness. That's all good. The problem is the laser cutter only works two-dimensional. So this is all I can give the laser cutter. And I have to imagine now the material thickness of my foam core, which we're going to use. And let's go to this layer and you will see actually how maybe you have to prepare actually your different walls and the width. So later when we laser cut everything, you can just stack it back together and it will all fit. So you see actually that here I have my front and my back wall and they are as wide as my base plate. But you notice that actually my shorter side walls are not as wide actually as the base plate. Because if I would make them as wide, obviously, so let's say we cut this out of the foam core, you will see that, well, they intersect. So that's the reason why, for example, you have to develop a system to understand where, for example, can you keep walls as wide as needed, for example, here in relationship to the base plate, and where do you have to make walls only as wide as the inner length of that wall, not the outer length, because we don't really want to miter all those edges. We just want to make straight 90-degree cuts on the laser cutter, no extra sanding afterwards, and then simply glue everything together. So you see here in my case, I simply decided to make the side walls only as wide as the inner length or width and not the outer one. And for example here, everything what you see, those are then all the outlines what actually the laser cutter needs. So for example, the diameter for the wall and then the diameter and the position of a window. If, for example, here in this case, we also would like to maintain a door, then actually we can actually in this case also include, let me remove this one, actually this line I didn't really need. Yeah, that face I meant. All I need is just this line, because the laser cutter will cut along these 3 lines like a U, and then it cuts along this line, and then I have a door which I could either put back in, rotate, glue in with a pin or something, have it on a hinge. And you see actually if I move these parts around a little bit, so this one and this one, they are all as wide as, for example, the base plates are. So you see it perfectly lines up. Now if I take this one and move it next to here, you will see that this is not as wide. And again, that's because those smaller pieces, in my case, I have to make only as wide as the inner length. Now, you have here, for example, a width of 8 inches. Now we scale it all down, and that's a tricky part. Essentially, you want to work with a scaled material, but probably you can just buy foam core with certain thicknesses, and that's it. So wall thickness, you have to sacrifice a little bit of accuracy. However, for the rest, length, height of a wall, etc., there we can be very, very specific. So here you see the elevation views and also the floor plan I did for the base in AutoCAD. Everything neatly lined up. All I need again are just the outlines for the walls and the openings for doors and windows. And the current version of Illustrator has a bug when it comes to importing native AutoCAD files, but I notice actually we can simply export this design as a PDF and then import that PDF or open that PDF in Illustrator. So in Illustrator, I go open and let's take a look. Where's the floor plan? There's floor plan PDF. Perfect. So there are two things we have to do. First, clean up our drawing a little bit, and then we can actually adjust the scale. So when you go to layers, you will see that this actually is inside a clipping mask. So if I click on it, you see I have a big boundary box. I don't really like this. I want to get rid of it. So I go to Object, Clipping Mask, and Release. Now you see it says layer, and I only have all these objects. This is much better. See, those are all individual lines. Okay, that's fine. So I can select everything and then press Ctrl G or Apple G or go to the object menu and go group. So it's actually one object. So what we have to do now is actually set our document to the size of our print material. So I go to the artboard and set this to tabloid. Landscape is fine. Okay, good. What's this one here? That one we don't need. Okay, and we can move this one to there. Because currently we don't really know how long, for example, this line is. So let's go to Preferences and Units, and let's say set this one to inches. Okay. So there was somewhere the ruler. Hold on, where's it hidden again? There. So let's see. This to there is roughly, oh, it's an inch. So 10 feet equals 1 inch. So the tricky thing is now you need to figure out a good scale format. So your print objects won't be too big. So you can pack everything nicely onto one sheet, or they're not too small, so the model will be like too small. So for example, we can take this one, and I'm just curious how big everything will be if we just scale it across the complete sheet. So let's go back to the measurement tool and quickly preview how much that would be. So 3 inches. Yeah, that's for example not bad of a size. It's still maybe a little bit small. Maybe I would like this one to be like 5 inches. So I can go to the line segment, click somewhere. So I just mouse click, type in 5 inches, angle 0, okay, then 90, okay, good. So now this is kind of like the height reference of how high something should be. So I move this one to there, press Ctrl Y or Apple Y, so I'm in preview, because then I can drag this one and snap to there. In case you don't see anything snapping, press Apple U or Ctrl U. And the main reason for that is now I can select this whole object there and press S for scale, move this one to there, and then scale till, here you see it hits, and you see I'm pressing and holding shift, so I scale at the same time. There. Okay, let's do this one more time. So I click this whole group, press S, then you see there is a magenta, a cyan small cross. I can move this one and snap to that point. And here click and with shift pressed move this one down till it actually snaps to the end of this line. Release, and ooh, I forgot to press shift. Oh, I can't go. Then I have to go this way because I only scaled along one direction, unfortunately. But here at one point you will see it tells you this is actually now at this correct height. So let's double check. Yeah, this is pretty close. Okay. So let's take a look and move this one around a little bit. Yeah, so there we see now, close. Doesn't perfectly fit on. So this one wall sticks out. So what we have to do now in this case is I can click my whole object, go ungroup, and for example, select all those edges here, there, that's a rectangle. This actually I group again. And let's see where I can move this one to. There. Well, maybe I zoom in, move my mouse to this corner, click and drag, and make it snap to there. Then I drag everything, Control G or Apple G, group it, and maybe move it actually onto that page. So actually in this case, I'm lucky enough that I actually can fit everything onto one page with walls which are roughly 5 feet actually tall, representing kind of like 10 feet. So that model has a sufficient size, and I'm only using one sheet. So this one, for example, then we simply save, and that would be now ready for the laser cutter. So let's go back actually to this model, because everything is very easy when you have straight walls, but dear Lord, what happens when you have round walls? Not really tricky, a little bit more work, but there are some very easy ways how we can approach this. So essentially, you need to, for a certain degree, understand how maybe you could build something round like this. And the way how I would do this is simply kind of like this. So we take actually a sheet, and then on the outside, not the inside, the outside, I make a lot of cuts. Because this is circular, these cuts should be as smooth as possible. And then I wrap it around and make one end meet the other end. And then actually we have actually a cylindrical shape. The only problem is we see all those small gaps here. Well, we could also do the opposite. Actually, we cut in the inside those gaps, but then we have to file a certain amount of material out. So when we fold it, you see here those triangular shapes are open. Think about the reverse. The triangular shapes here are filled because we sand it in small gaps to be closed. The reason why I like this a little bit more is it's less work. I don't have to sand all those gaps perfectly. And this is just my wall filler. This is not my final design. Because then I can go to something like this here. Hold on. Let's overlay it this way. Don't fill my rim. Don't do the boolean for the moment. So you see here I have an outside and an inside shell. Think about this as a sheet of paper which I just fold into the shape of a cylinder, and then later with some glue the inside, well, maybe the inside we don't need, but at least for the outside we just glue and roll it over it, and that's basically it. The other thing why this approach in my opinion works better with those triangles outside is also, well, if you want to make an oval, etc., this is going to be very, very easy. So you first need, of course, to figure out how many of those or how long does this piece have to be so that we can roll it into a circle with the correct dimension or diameter. And then, well, all the cuts, folding it. The other thing that might look a little bit tricky is now, well, how do we do if we have to cut something out? Well, we can also do something like this, where now that's kind of like the shape you have, and hold on, I forgot to add the solidify modifier here. There, zip, opposite direction. So here I know, for example, if I start somewhere and I roll it around, at the center of the sheet is the door, and I roll it back, there like those two ends actually meet. So there I know that, well, then here I need to have a piece like this where the door is perfectly positioned at the center. If I have somewhere at the sides a door, then, well, here at the center of those sides I need to have the opening for the doors or the windows. And it's basically a little bit of trial and error. And what I would do is, before I work with foam core, just work with a sheet of paper, cut those shapes out, and then roll this into the shape you need and see if everything fits. If that template then works, then go ahead, make the drawing for the laser cutter, cut the foam core piece out, and then take an X-Acto knife, cut in all these grooves, and bend the piece into the shape. And in this way, recreating something like this out of foam core and a laser cutter is also not really a big problem.